Why do we call it related rates of change? You've got rates of change all the time, like if I'm walking across here, I'm walking at 10 centimetres per second or something. So I've got a rate of change. So what do we call it? Related rates of change? We've got three things. Someone made up the name related. These are three things. My brain wants to just fall over here and go to that, but we'll do it implicitly. So we know we're getting the area of a triangle. We know that we've got the sides and we've got the angle in between. So what have I got for the area of the triangle? Each of the sides is x. So I've got x squared. You need the diagram, or do you see it in your head? Do you?
I see it in my head.
What if someone doesn't and they're watching? So I've got x, x, and x, and that's pi on 3. So that's just the sine of pi on 3. Could go degrees. And what have I got then? So here's our new formula. We've turned that formula with some restrictions into that formula. Tidy it up.
Root 3 on 4x.
Thank you. Root 3 on 4x squared. Now we know we're going to differentiate it. We know we're going to go dA dx somewhere along the line, so you could do it during the question or you could do it up there. I'll do it up there. What have I got? Root 3, so times by 2 on 2 of x. You okay? So let's go back to our formula that we've got here. Now what did they ask us to get?
Coming out the rate of increase.
Well, we know this one here. They've told us that, haven't they? So what's that one? The length of each side is constantly increasing in that. So the length of each side is constantly increasing. So in other words, we're comparing that to time at 10. Yeah? And be careful that they're talking about that centimetres per minute. But everything else we've got is in terms of metres. So I could turn that to centimetres, or I could turn that back to. So I could go.
That could be 0.1 metres per minute.
So 100 centimetres, 0.1 metres per minute. I think I would do that first every time, because it's too easy to muck it up and look back later and go, oh, I stuffed it up again. What else have I got? What did they want? They wanted us to get the words. The rate of increase of the area. So here's the big one. I feel like I should get a different pen or something and go, we want the change of the area with respect to time. So that's what we're looking for. And everything in my brain wants to go, we're looking for dA dt. So we can write that as dA and we can write it as dt. And what's the extra letter we need in this question?
dx.
Yeah. And my default position, and no matter what I look at what other people do, goes back to that. Because then I can just put the other two in, write the answer down. So what do I want? I've got A is, make sure I get it right, root 3 on 4 x squared, leave some space. If I said I want to differentiate them using time, why are we doing time? Because most things are time, but not everything, but most things we're going to do are going to be time. Do you just see that in your head? Just the ADT?
Yep.
Definite, absolutely.
I think so.
So if you didn't, what would you have to go? I want the letter A, so I need a dA with a dA. So on this one, what letters do I need?
dx on dx.
dx on dx. So I got the derivative of that, which you see in your head as
root 3 on 2x multiplied by dx on dt.
Got it. Now we show him what we've got and write the answer down. We're wanting that, that's what we're looking for. I've got that. I could write this. We want the ADT when x is 0.5. And so I've got to write in the 0.5 and then I go dx dt. It said it was constantly increasing at that rate. Is that the one we want? Yep, so dx dt was 10 centimetres, so we change it back to 0.1 and we write the answer in. Well, I left them all as decimals. That'd be easier to go root 3 on 2 with a half and a tenth, isn't it? So all I've got is root 3 on 40. And what's our units? Now give out the units for a moment.
Centimetres squared. No, metres squared.
meters squared per minute. And I deliberately wanted to go sort of different units. You okay with that? Now, this, I don't know, I don't really have to think about, but having different letters. So ready, we'll do it the other way. I'll just look up for a sec. So if I do it this way instead of that, the ADX is, I've already got it written up here, but I could have gone differentiate that and do it, but I already had it written as root 3 on 2x times y.
dxdt,
which is consistent, we know,
which is
0.1. And then, if I could have done it all in one line, I could have gone to ADT when x is 0.5, and you're back to the same calculation. And again, I did as decimals when it's better to do it as fractions. Easy enough?
Yep.
Same answer, root 3 on 40. So what I want to do with you guys is say, it's your choice.